Good morning. My name is David Smith. I am a cybersecurity architect from Schneider Electric. However, today I am here more speaking about UAFX as a member of UAFX um, and about the design choices that we made for integrating PubSub security into UAFX and how PubSub security is implemented. So first, a little bit of an introduction to UAFX. I'm sure Paul covered quite a bit of it. It is an attempt, its goal, its mission is to extend OPCUA to the field bus. And we use PubSub communication for data exchange to do so. There is client server management. So that is used, say, to establish and control connections. And eventually, we will also include time-sensitive network into this as well. The first edition of the specification was released in 2022, and we're actively working on maintenance updates and part 2 focusing on controller to devices right now. We did have 3 major areas of direction given to us for security requirements. The first was to ensure interoperability between devices and UAFX. This required us to look at all IT protocols as well as optional core UA features, and then to include them in profiles. From security point of view, this meant everything from mandating use of NTP for time synchronization to using elliptic curve cipher suites for efficiency for embedded devices, requiring the use of X509 certificates for controllers to connect to each other and to use as user tokens to authenticate and establish sessions. We also had to do some peering into the future to when controllers would talk to field devices so that the architecture that we designed for controller to controller would also be applicable to controller to devices, especially when we take into account that devices will generally have lower resources, lower compute, lower memory. The second feature, or the second direction, was we were to use and reuse as much as existing the OPCUA functionality. OPCUA was designed with security in mind from the ground up, so this was a no-brainer. We would like to reuse all the wonderful work that has been put into the standard in the past. There's no reason to reinvent the wheel here. So for client server, we reused all the secure conversation functionality in UATCP. This included creating the secure channel, session management, role-based access control, and certificate management functionality. We have mandated the push mode for certificate management for client server. For PubSub security, we used UADP message security functionality to ensure data packets were protected from disclosure and tampering, and we reused the key distribution mechanism from PubSub to ensure key material was securely distributed to endpoints. As I mentioned as previously, we require NTP for time synchronization, and then there's other discussions ongoing about things like DNS moving forward. And lastly, to support both the interoperability and the reuse missions was to standardize this into profiles. So we have a controller profile that standardizes all the optional components that we picked from the UA specification, plus other external requirements, like I said, about NTP. And those conformance units will be tested, as Paul just mentioned, in the upcoming releases of the CTT tool. So I think it was quite fortuitous that Paul was presenting just before me on this topic. A little bit of an introduction on PubSub and its security mechanisms. PubSub does support cyclic data exchange. It also does support other modes like change of state or acyclic events. For UAFX, the most important use case for us was this cyclic data exchange. And most often we're going to be doing this over UADP, which is the UDP message format for PubSub. Supporting primarily one-to-one data exchange and one-to-many multicast exchange as well. Between endpoints, data can be sent through the network infrastructure. There's no need to do anything else. Just use UADP. If you are sending data to the cloud, PubSub messages can be sent through a broker using MQTT. For UADP, The message security is implemented on the payload. This means that it really does not require any other secure envelope mechanism. So MQTT can use HTTPS to wrap a message further. So you could technically encrypt a message so that the broker can't see the payload inside, if you so wanted. For efficiency and speed, symmetric algorithms are used. So we're using AES counter 128 and 256 for the bit size for the keys. And then HMAX SHA-256 is used for the message authentication code, or what is called the signature. So the message authentication code protects integrity, and the AES mode protects the confidentiality of the data in the payload. For performance reasons, if you so wish, and you don't quite have a concern about the confidentiality of your data payload, you can run UADP PubSub security in a sign-only mode, which means the AES counter mode is not used to encrypt the payload, but you do use the HMAC SHA-256 to create the signature. For something like high performance motion, where waypoints along the way are not a serious concern for intellectual property theft, and really all you care is that the machine moves in the manner in which you specify, then this is certainly a very valid application. Lastly, for each PubSub connection, there are individual security groups. And those security groups contain information like the security keys to be used, the encryption modes, the key lifetime, and some more information about that specific PubSub connection. So a brief primer, again, more of an introduction as well around the UAFX connection workflow. Most of the work started on UAFX was how do we create these connections in a dynamic manner with lots of robust capability checking between the participants. So the notion of this connection manager was created, and that is used to connect two automation components together. Those automation components may live on one device or another, and UAFX has actually mandated that each controller also contain a connection manager for interoperability reasons. The connection manager, using the methods available to it, the methods created for UAFX are the established connection methods, and the various functions inside of it create, configure, and validate the configuration between two different automation components. And then they tell the connection that it should be enabled and start to publish data. This being an integration of PubSub security into UAFX, I guess the big question is, where is the key distribution in this picture? We'll get there. But before we picked which way or how we wanted to do the key distribution, we had to evaluate different scenarios and workflows for UAFX. So these are, I would say, not so much different network topologies, but different choices in the data flow between end components. So one of the first evaluations we looked at was this push model, where, as I mentioned before, each controller has its own connection manager, and that connection manager is used to establish connections between the automation components and then start to push data. So in this picture, we decided that we would have a security key service, which is the key distribution mechanism for PubSub security, on the establishing controller or controller A. And this security key service would be configured by the internal connection manager, and then would be responsible for distributing keys to the publisher and subscriber in the network. So this is consistent with the connection manager workflow. It does create some problems though, in that the security key service that is established, that is inside each of the controller, has to be more complex It has to keep track of key lifetimes. It has to anticipate when keys need to be refreshed, and it has to autonomously, by itself, create client connections to external partners in order to push keys. So it certainly creates more complexity for the controller to implement than, say, something like the pull model, where the publisher and the subscriber, it's a very slight difference in description here, where the publisher arrow is requesting the security key from the SKS, as opposed to the security key service pushing. So it's very slight difference. But what it does buy you, if you implement this, is a less complex mechanism for key distribution, because now you'll have just the server of the SKS implemented, and the functionality to do so is quite minimal. The publisher and subscriber know the key lifetime. They are configured to know how fast they produce data and how often they should be receiving data. Plus, they can see the message counter that is used to keep track of the key lifetime, and can anticipate when they need to do updates. The downside to this is that each controller will also need a client. For something like a controller, this is not a problem. We already have the connection manager, which is a client to establish connections. But when we start, as I said, looking forward to the future for controller to devices, devices being simpler and less capable may not have clients on them. So we didn't want to standardize on something like a pull model, because in the future, we think we would run into problems with devices trying to support this functionality. And then the last we looked at was a centralized system management view, where if we have a totally separate entity that is used to create, manage, track, and diagnose connections, we should also have a centralized system as well for the security key service. This is more about systems at scale. So DCS plants, continuous process plants, where you have thousands of nodes, or things are set up one time and then monitored over their lifetime. This is certainly a valid use case that we had to look at as well. Much like the push model for the controller to controller, it makes sense to pattern the connection data workflow after the connection manager. There would be client functionality already there, configuration, how to talk to devices is already there. If there are routes or paths through firewalls that need to be configured, the connection manager should already know how to do that. So from a data flow point of view, this would be a very good pattern to have as well. And push mode for the secure centralized mechanism should work as well. So the obvious choice was then to go with the push model. This decision was to mostly ensure interoperability between controllers. What we did not want was to have the security key service as a client in controllers to be optional. And the off chance that an end user bought two different controllers from two different vendors, and both of them were the lightweight, if you will, controller that did not include the security key service. In which case, when the customer set up their system and tried to turn on security or use the security as default, they would not be able to configure any security keys. So their installation would be effectively dead in the water until they bought the right device or purchased the right firmware for that device. This also helps us, as I mentioned before, in the future with devices. The controller is considered to be a capable device. There is lots of functionality that is baked into it. The connection manager has quite a bit of robust validity checking during the connection establishment process. So there is CPU cycles available. There is memory available for the controller to use for management functionality. When we get into the devices, it might be a bit more difficult to justify that. And if we're looking at something like a machine network in the future where the controller is connected to the devices and the devices are segregated from the rest of the network physically, then the controller has domain over those devices. So it will be responsible for configuring and managing those devices. So this was all great. We had our data model. We had our PubSub security payload mechanisms, but we ran into a problem. When we started working on UAFX version 104 was the release version of OPCDI, and PubSub did not have full support for this push model for distributing keys. It had, for the devices, the methods to call to be able to push keys to the devices, but the security key service did not have a configuration mechanism to know how to connect to those devices. So the Part 14 group worked to add this functionality into the information model for the security key service. They called it the push target. And this contains all the information required to connect to a end device to distribute keys. So in addition to the security group, which includes things like the encryption mode, the keys, number of keys, the key lifetime, and some other information, we now know how to connect to that security group with the application URI, endpoint URI, the security mode to connect to that end device, and then there's other mechanisms as well. So this now allows the security key service to be aware of everything it needs to know to manage and update keys for a PubSub connection. Also includes other mechanisms like rotate keys and invalidate keys for the full management. So I mentioned quite a few times now about updating keys and why this is important. Keys do have a lifetime in PubSub. They are connected to a 32-bit counter that is incrementally counting up with each PubSub message. The specification says to ensure the adequate lifetime of the key, that key should begin being updated about halfway through the maximum lifetime. So this is quite fine if you are publishing at something like 50 milliseconds, where it's almost 3 full years before you have to update a key. So that's not so much a problem. But if you are publishing data at, say, 31.25 microseconds, which is a time frame that is required in the specification for motion, then you should be trying to update your keys every day. So this is 3/4 of a day. This does pose a problem. Obviously, if you have a large number of devices and you're trying to make these key updates constantly, you can run into issues like network connectivity problems, hardware problems, software problems that interrupt your ability to make this client-server connection to update the keys. So there is a mechanism in the push method to update more than, say, just one key. Technically, the way that we usually do this for the update keys, that's what's specified, is you start with 3, which is the last key, just in case you have to reconstruct old messages, the current key, and the next key. You can, however, distribute more, say 5, 7, 10, 100. It's up to you. It's part of a configuration that a vendor would implement to make this robustness a value add feature for that customer. So the full UAFX workflow. We have our connection manager, as we mentioned before. Now we have the security methods layered on top, or integrated, I should say. The first thing that we do with the connection manager is it actually contacts the security key service, and it creates the security groups and the push target information for the end devices. It already knows all this information. When creating the security group, we get back a little bit of information about the security group, mostly the security group ID and some other stuff, and that is actually used during the configuration of the PubSub connection, which the connection manager does next. It uses the established connection methods to create and configure the PubSub information on the endpoints. The connection manager then tells the security key service to connect the push targets to the security group, which triggers some autonomous functionality in the security key service to act as a client to connect to the automation components and push the keys to the devices using the set security keys method. Next, the connection manager enables the connection between the two automation components, and at which point the PubSub data can start to exchange data between the publisher and subscriber. So this is the full UAFX workflow, or connection management with security enabled. And the last mission that we had was standardization. We do have a number of profiles and facets that were created. Paul highlighted those as well. They are available right now on the UA profile page. The biggest thing to look at would be this UAFX controller profile 2023. For security, it breaks down into a number of different profiles and facets. The UAFX controller profile includes the connection manager profile, which includes things like the SKS push facet, which supports all the security key management. And then the UAFX controller server profile includes a lot of other functionality related to security. So auditing, time synchronization, user tokens for authentication and session establishment, and a number of other security mechanisms. Lastly, this was a group effort. The whole UAFX effort is a collaboration between multiple companies using the standardization platform that is UA to really create an ecosystem for end customers. So with that is a massive amount of collaboration in the UAFX work group. Part 14 was very helpful in modeling the push behavior to support UAFX, adding that to the specification. The prototyping working group worked really hard to support that Part 14 edition and also the connection manager and security integration as well. The connecting devices in the architecture working group really helped in modeling the connection manager workflow for the security mechanisms as well. So it was quite a bit of a group effort. With that, I myself am done as well.